Good morning. I'm so glad you've joined this online training session. I'm Dr. Derek Fish. I'm director of the UniZulu Science Centre, and I'm delighted to be working with the South African Institute of Physics on this project. You're going to get some fantastic help this morning from some of the best experts in the game. The only problem is that after 2 hours, that help will be over. I want to tell you about some resources the Institute of Physics has made available, which will continue to help you throughout the year, anytime you need them. And the best thing is, they're absolutely free. Let me tell you about the essential skills resources, which I developed in 2020 during COVID. I've been running matric workshops for over 30 years. And during 2020, when we couldn't go to schools, we made videos of all these resources. We called it essential skills because of the idea that facts fade, experiments expire, but skills stick. And every year, the examiner identifies the fact that the main thing lacking in students is not so much knowledge, but the skills. So this was the basis. We identified 4 essential skills for physics for paper 1. That was graphs, free body diagrams, solving equations, multiple choice and ratio questions. I'll show you how these skills cover all 10 of the questions in paper 1. Graphs, we further broke down into 4 examples: motion graphs, photoelectric effect, Ohm's law, and internal resistance. And again, this is the comment from the examiner himself. A severe lack of skills is evident. Mathematical, conceptual, and integration of topics, free body diagrams, graphs, and equations. So that's what we have tackled here. The section on equations, we expanded to actually cover all of those long questions which involve solving equations. Now, you will see that every single one of the questions is covered here, not necessarily in the same order as a textbook. And these videos and the booklet that goes with it are not a textbook. They do not replace your textbook or your teacher or your notes. They're a revision tool for you to use in preparing for exams. Use them immediately in preparing for June. Use them again in preparing for September trials, and especially for your finals in November. So they're grounded on the curriculum. The relevant theory is covered, but just in brief, experiments are performed, simulations studied, and exam questions are explored, not just in giving the answers. You don't need that because you have memos, but just explaining strategy and how to answer that. There is a booklet which you can obtain through the Institute of Physics, or otherwise I'll show you how to download it from the website. This is the contents page, and you can see the skills, graphs, free body diagrams, equations, multiple choice. The equation section in red is much longer, and is actually expanded to cover all the different types of equations which will come up during that exam. And again, a comment from the examiner: learners still cannot work with scientific equations or formulae. When the theory is covered, it's covered in a very interesting way. For example, you'll talk about Doppler effect today. I use lots of exciting animations to make the concepts clearer. There are also lots of summaries. The strategy for problem solving will be introduced, and a summary of all the graphs of motion that you will come across in matric. And this very useful table for choosing the correct equation of motion when you might not be too sure, particularly for projectile motion, question 3. I cover the syllabus experiments, and for example, this is the internal resistance experiment, and it's covered using fantastic Pasco software and hardware so that you can actually participate in the experiment. Also, lots of useful simulations, particularly from PHET, the photoelectric effect. You'll talk about projectile motion today, and also momentum. And then talk about applications like, what would the International Space Station be without its solar panels to generate electricity? When we talk about exams, we make comparisons of at least 3 years of exam questions, looking for common trends and strategies that you can rely on. And let me tell you just how to get hold of these. If you go to the Institute of Physics website and you look up matric material, it'll take you to this page. If you scroll down on that page, you simply ask to fill in your details. This is just so that we can track the use of these resources, but the resources are absolutely free. Press the submit button, and that will take you into this Google Drive where all the materials are available, either to be used online or to download. Here I am on the actual website. You can see all the different files that are there. So the main physics videos are in this folder. If we double click on that, then you can see all 16 of the videos. They're about an hour long each. So this is not something you should use only in November. Start using these fantastic resources now, and they will help you throughout the year. Here are the booklet parts, and you can see their PDFs. It's just a few pages at a time. For example, if we open the one on graphs, it'll show you a PDF with all the relevant pages that you would use and fill in all the exam questions while you are actually watching the video on this point. These, of course, you can watch on screen, or you can decide to print out. We also have exam papers and exam memos, and you can see you don't need to go to the website to look these up. Here are all the physics November exam papers from 2014 all the way through to current. Don't go back before 2014, because that was before the CAPS curriculum. So everything you need is here. There are also all these things for chemistry as well, but we're going to talk about that next Saturday. There's a promo video, a letter explaining things, and all the contents. This is a fantastic resource, and I hope you're going to make the most of this. And you can pause it, fast forward, or rewind as much as you want. If you don't like the sound of my voice, you can just mute me. I wish you all the best for your exams. I won't wish you good luck, because that only helps with the multiple choice. But I hope you'll work hard and join us in the physics community in the future. Thanks for watching.
You have played for Kaiser Chiefs, for Marisburg United. You are a mechanical engineer. Looking back on your journey, what are you most grateful for?
I'm most grateful for the people that I've encountered.
Brandon, I always say to so many young people that there is a difference between calling and purpose. Right? Calling is what you're called to do on earth. Purpose is malleable, right? It's dynamic. You can change it depending on where you are in the stage of your life. What would you say your calling is, and what your purpose is ultimately?
Oh, that's a tough one. My purpose, I believe, was to sort of be a game changer, be a dynamic game changer, as you just mentioned. I always wanted to prove to people that you can have multiple talents, you can have multiple fields that you excel in. And that was just solely based off the fact that I was once told that you won't be able to play football and study engineering, and that sort of set me on a trajectory to say, why can't I? So I truly believe that in that game changing. In that moment, I had a purpose to sort of prove, that this is possible, and be a trendsetter basically, because I believe that there are a lot of people that are trying to do the same and can do the same and achieve what they want to achieve in both aspects.
I want you to complete the following sentences for me. Success to me is?
Success to me is being grateful, being happy, enjoying the steps of life that you take. Not only success in the tangible, but success in the mental, in the physical, in the emotional as well.
You are deep, brother. Purpose is?
Purpose is passion. You find your purpose through your passion.
When the world and life gets to you, where do you run to? Or who do you run to?
Well, firstly, I run to my wife.
She's the CEO.
Yeah, you know that. So she's the first point of contact when I need some advice, when I need some guidance. I run to my parents. My older brother, I'm a middle child of three, so my older brother gives me advice, but my younger brother as well too looks to me for advice.
And he's also a football player.
Yeah, football player. My older brother's actually a coach at DDC Golden Arrows. So
did my research.
Yeah, I know. So I seek advice from him, but I also give advice because there's someone behind me that's actually trying to do what I did as well too. So
okay, I want you to look into that camera and speak to the soul of a high school student or a university student who feels like there's no value for their life. I want you to speak to their soul.
You determine your value. Your worth is determined by you and what you set out to achieve. Block out the noise, focus on yourself, and focus on the people around you that are pushing you to be better and do better, because they believe in you. So why wouldn't you believe in yourself?
Block out the nonsense and focus on what matters.
Yes, definitely.
You matter. A pleasure.
Thanks for having me, sir.
Hello, Itumeneng. How are you?
I'm good, thanks. And
Great. Thank you so much for joining us.
yeah,
Why is the study of science so important?
study of science is important. Let me speak directly to physics. Physics is vast, and there's a lot to learn in physics. There's a lot to learn in a sense that you wouldn't know if you're just sitting out there not doing anything, just reading and doing, like reading can make you realize a lot of things, especially with physics. Like myself, I didn't know about this resistive switching memories up until Dr. Dlamini from the Central University of Technology introduced this to me, and then it caught my attention. And say, yeah, with all the challenges that comes with it, I just felt like, you know what, I'm up for the challenge. Let's go, let's do it.
Let's do it. All right. So I know that there's a lot of young people who are in high school who are quite skeptical about venturing into careers that have to do with physics specifically. What advice would you give to such a young person?
I will speak to say, not giving up. I was in high school at some time, and they wouldn't believe me when I say I did fail physics and maths. I did get 0 at some point.
Seriously?
I failed grade 10 3 times.
But look at you now.
Now I'm doing PhD. Looking back, it's like, it never happened. So yeah, not giving up, just like have the intention, the dedication to do what you want to do, what you have to do.
And of course, resilience, perseverance, it becomes very important.
Yeah.
Just like yourself, I am a product of SMU, Sefako Mahato Health Sciences University. And I think that being in such an institution where you are exposed to different people from different walks of life And eventually, when you go into the science stream, the physics stream specifically, then you start to see just how these concepts can be applicable in our daily lives. Just really makes you fall deeper and deeper in love with the subject itself. Was that for you as well?
Yeah, it was the same for me. Like I said, somewhere, somehow I did get some zeros there.
Yeah.
But then through dedication and, you know, coming from where I come from, and you are at this side, you've made it to university. Somewhere, somehow, winning is the only option. You have to win, like it or not. You going back to where you come from, you're just going back to that life of drugs and whatnot, and that's not an option, I guess. So winning was the only option coming this side.
So we are in June right now, and learners are writing their June examinations. So to those who are writing physical sciences, what words of encouragement would you like to share with them?
I think study before, like you prepare, like you always prepare yourself to writing. You can be a genius whatsoever, but then if you're not studying, preparing for your exams, I don't think somehow you're bound to fail. So preparing for your exams in time and making sure you consult your teachers and whatnot, I think you'll get there eventually.
You know what they say, if you fail to plan, you plan to fail.
Yes.
So study and be prepared. And there's no need for them to be anxious or nervous. I mean, if you could fail grade 10 three times, and now in 2025, you are a PhD student in physics, anything is possible.
And I'm a lecturer, by the way.
And
I'm a part-time lecturer at the physics department.
Listen to that. Listen to that. Thank you so much. Really appreciate it. What's the future looking like?
The future is looking to resistive switching memories. I think, the future just looks bright. I think it's going to do wonders in the future. And I'm just looking forward to that. Also, in the academic area, I think so far so good. Lecturing is going well. And I think, everything about the future just looks bright.
Okay, thank you so much. All right, ladies and gentlemen, my name is Mukosi Mashele. It's a wrap. Thank you so much for indulging us in our conversations. Until the next one, bye.
I'm Jade Morano. Ever since I was younger, I would gaze at the stars with my late grandmother, and from there on, I've had this deeply rooted passion to understand the universe I would look at all the time. It enables me to one day come up with an innovative idea or discover something that could benefit our society and help us grow scientifically. Honestly, every topic involving the stars and astronomy really excites me since it's very much up my alley. I aspire to become a theoretical physicist, so mathematics and physical sciences are fundamental subjects required to pursue my career. Physics can be challenging, but very rewarding, so always test your limitations and surprise yourself. I think that physics is seen as a male-dominated industry, so I would like to flip that perspective and challenge all young women out there to believe in yourself and to really test your limits and see how far you can go in physics to change this perspective. Yeah.
My name is Tamaka Madicha. Having the passion to acquire incredible knowledge, as physics is that one subject that defines life as we know it. Having to do calculations and learning knowledge that's beyond every other subject, like geography or history. Physics is just that one excellent subject. Everything with physics in general, especially calculations, makes me want to learn more, as physics can prove life as we know it. I'd like to become an airline pilot, and physics in the aviation sector will help understand aerodynamics, including lift, drag, or airflow, which will help engineers design aircrafts and the technologies. If you love it, it will be excellent for you. Physics, when you learn physics, you step into a different dimension. So do it with passion, do it with love.
Physical science is very bad, then it means the whole science, engineering, and technology is bad. And we also call it the physics of today is the technology of tomorrow. I think those of you who have been listening to the news, you heard that the Nobel Prize for this year was given to the people in physics who invented AI. I think most of you are using AI, Snapchat, and so forth, but that's from physical science. So maybe next time it will be one of you discovering that. And here is a lot of the areas in which physical science people work.
So think about the physics. If they're saying be in the kitchen, make use of that kitchen to be a genius. Brian has said what a genius is. So I am saying you are all geniuses. You are all going to make it. What I want to tell you is believe in yourself. You are going to make it. You can do it.
Which topic is difficult? Which do you think is difficult? Yes, with energy and power. You know why you say it's difficult? You say it's difficult because when they ask you and say, use energy principle, you don't know which one to use. And the heating on the surface of this metal, and then if the frequency is of high enough energy, we are going to have what? Electrons ejected there. And you can even see that with these ones here, where are the electrons themselves? Because they are going to be ejected with different velocities, depending on where the electron was. Let's say the electron was somewhere here. Here, it's there. It means that the light will come down to there, impinge on that electron, and then the electron will go that way, assuming that there are no collisions at all. And then if there are collisions, it's going to reduce the kinetic energy of that, and then it will dash off. Okay, and then this one. Right, can you give me the answers now? I think you are now fine. I don't know whether you are all right. Or, but Ara, which one? Oh, sorry. Who said that? You. Tell me, which R? The small R, yes.
You say rice, A plus B is C. Initially, I have X of that, which is this one here, and nothing of it. Remember? Now the change comes. This is decreasing. You see that? I will have my minus T and a minus T, and in the meantime, this is starting to increase. Hence, I have my plus C. And And then at equilibrium, this is the end of your reaction. Nothing happens anymore. You are now on this block or portion. This is the equilibrium that you have here. Right. Hey, I'm not going to complete this one. You can leave it there for now.
What do we have over here?
Okay, so this is one of our smaller telescopes. It's a 6-inch telescope of Jupiter, and you'll also see the marks on Jupiter, sir.
No way, in South Africa.
Yes, sir.
Here, in
Yes,
the motherland. Chai.
All we'll ever trust, yeah. No, I don't wanna waste what's left. And on we'll go, through the wastelands, through the highways, till my shadow turns to sun rays. And on.
Okay. So the future is too bright, as you can see with my upgraded sunglasses. So I'm standing next to the South African Quantum Technology Initiative stall or exhibition stall here at the National Science Week launch. And this is why, ladies and gentlemen, science rocks. And science is for everyone, just like that handsome fella over there. Hello, dude. Hey. Oh, it's me. All right.
Echoing around these walls, fighting to create a song. I don't wanna miss a beat.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
Morning, learners. Welcome to our good morning, learners. Welcome to our session. The session is on paper 1, physics. I want to take this opportunity to welcome you to the South African Institute of Physics Final Matric Exam Preparation Workshop. My name is Ali Letswalo from University of Limpopo. I'm with Dr. Molf Molefe from University of Johannesburg. We'll be going through physical science paper 1, as I've indicated. And please get pen, paper, and calculator so that we can do some exercises together. Just make sure that you have your scribbler, your pen or pencil, and paper handy. We are going to write a lot of things today. So the exam is upcoming, and you'll get a question paper that looks something like this. That will be the physical science. It's paper 1. It's a 3-hour paper, and the total marks is 150. So in this session, we want us to engage so that you get most of those 150 marks in 3 hours in the next session, in the next exam session. Okay, now let's start. Let's start, ladies and gentlemen. Right. Now, physical science paper 1 consists of 3 major categories. That is mechanics, electricity, and waves. And there's also questions, multiple choice questions that covers all the 3 areas of paper 1. So I'm going to deal with mechanics, electricity and magnetism, waves, and of course, we'll start with the multiple choice questions. Now, the mechanics part consists of 4 questions. Normally, question number 2, which will be Newton's laws. Question number 3 will be vertical projectile motion. Question number 4 will be impulse and momentum. Question number 5 will be work, energy, and power. When it comes to electricity, we will be dealing with electrostatics. That is question number 7. Question number 8 will be electric circuits. Question number 9 will be electrodynamics. And question number 6, you see, after 5, we jump to 7 in electricity, but question number 6 is Doppler effect. And question number 10 is photoelectric effect and emission spectra. So you have 10 questions. Question number 1 is the multiple choice questions. Here you'll be assessed on the knowledge and understanding of concepts and applications of principles and laws. So that is the structure. So we have got 10 questions, and the questions on mechanics weigh about 50 marks, and electricities are plus minus 50 marks. Doppler effect and photoelectric effect plus minus 30 marks, and the multiple choice questions are it's always 20 marks. So you can see that there is a spread of marks that will constitute 150, and the idea is that in every question, try to get maximum marks, so that at the end, you have very close to 150. So the total mark is 150, and that is the structure of the question paper, and the marks allocation, and the topics that you will be assessed on. Okay, what will you be assessed on? You'll be assessed on the concepts. You'll be expected to be able to define concepts, to state certain laws about certain concepts, to give examples, and to explain. So you need to be prepared to write down. We're going to write quite a number of explanations, definitions. You are going to state certain things, and you will be requested to give examples. Secondly, the relationship between concepts, quantities, and laws. Physics is about relationships between concepts, quantities, and laws. You'll be assessed on that. As we'll see as we go along, the representation. You'll be requested to be able to represent these principles, concepts, laws diagrammatically with graphs and using formulas. So be ready to draw graphs or interpret graphs, be ready to draw diagrams, and be ready to use formulas. Okay. And You see, we have got question 1, question 2, question 3, question 4, up to question 10. But some of the questions will be integrated. That means the concept in question 2 might be requested in question 5. So that integration, you'll be assessed as whether you'll be able to move from forces when we do Newton's laws and forces when we do work, energy, and power. And lastly, you'll be requested to state the laws and the principle and apply them. So the skills that you need to do that, you are going to calculate, you are going to apply, you are going to analyze, you are going to interpret. So that is what the paper consists of, what you are expected to do. In short, we define, you state, you explain, you describe, and then you apply your skills, solving skills, drawing, interpreting, calculating, analyzing, identifying, compare, and evaluate. We are going to do quite a number of exercises where we will practice all this. Now, in this paper, there are concepts that you must know. You must be able to define and to state. There are 36 physics concepts to be stated and defined. And that will constitute about 20 marks in the paper. These are the concepts. These ones, just make sure that you know. They are in every section. If you look at your exam guideline, they are explained explicitly for every section. For Newton's laws, they are stated or prescribed concepts. Momentum, they are prescribed concepts. And these are almost free 20 marks because you just have to know that and reproduce it. Let's start with mechanics concepts. You are expected to know very well what the normal force is, what the frictional force is, what the static frictional force is, kinetic frictional force, Newton's first law, and so on and so on. The important thing about this concept is that you must not summarize them in such a way that you lose important words in the explanation or when you state them. For example, when you are asked what is a normal force, you cannot just say the normal force is a component of force exerted on an object. The word surface must be there because normal force is a surface force. It only exists when an object is interacting with the surface. So words like that, make sure that you are very clear about that. Newton's second law, if you say when a force acts on an object, you lose marks. You must indicate that we are talking about the net force or the resultant force. When you are asked about Newton's third law of motion, somewhere in the statement, you must have the word simultaneously. If you leave it out, the whole definition is out. So you do in all of them, Just make sure that they are there in your exam guideline. Make sure that the 36 concepts, you know them so that you can get those 20 marks. They are there. There is no way that you will not have something to state or to define. If you look at vertical projectile motion, for example, many learners lose marks because they forgot to say they just say gravitational force. They say an object which has been given an initial velocity and then moves under the influence of gravitational force, and they put a full stop. You must indicate that it's gravitational force only. The only is very, very important. If they ask about free fall, one of this is going to be asked. Motion during which the word only is critical, because if it is not there, then the whole explanation or definition falls by the wayside. Learners, please consult that guideline for every question. Identify which concepts you must know and know very well. That will give you free 20 marks. You need to collect as many marks as possible in every question. When you come to electricity, there are concepts there, Coulomb's law that you need to define or to state, electric field at a point, Ohm's law, power, EMF, RMS value, RMS potential difference, RMS current. You need to know them. You need to know them by heart, if I may say so. You need to be you know this, because then you already have 20 marks. In the case of sound and light waves concepts, you need to know what is Doppler effect. Is one of the questions, and that is one of the concepts that you need to know. Photoelectric effect, you need to know what is photoelectric field and understand it. It's not only knowing, know and understand, so that when you are asked to solve problems, you solve them with understanding. The threshold frequency and the work function. Those are the 36 concepts that you must collect marks on. Don't overlook them. You need those 20 marks. They can make or break a pass, a good pass, and not so good a pass. So to get a good pass, make sure that you know these 36 concepts. Okay. Now you need some assessment tools, knowledge, and understanding. For that, you need some assessment tool. The first one is that you'll be supplied towards the end or at the end of the question paper, you'll be supplied with physical constants. These are constants that you don't have to cram, but you must refer to them because you'll use them in formulas. For example, you cannot use G equals to 10 meters per second squared because you will be given that G is 9.8 meters per second. So you need this information. Please note that this information is available at the end of your question paper. You don't have to struggle what the charge of an electron is. You just go there and write it exactly as it is and use it in your calculations. So sometimes the question will not indicate, for example, it could say the Earth is attracting a certain object of certain mass, and they don't give you the mass of the Earth, which you'll use in the equation. Just go to the physical constant and go and look for the mass of the Earth. So it is very important that now, as you practice towards the final exam, go through those constants so that you are aware which constants are available and which constants are not available. You should be aware that the Planck's constant is there, the Coulomb's constant is there, and so on and so on. It is very important. It's an important tool that I cannot overemphasize that you must consult and make sure that you know what is there and what is not there. The next tool is the formulas. You are given formulas. Almost the last page of the question paper, you will be given formulas for each question. For example, the formula sheet looks like the one that is projected there. There are formulas for motion, formulas for forces, formulas for work, energy, and power, formulas for waves and sound, and so on and so on. All the questions have formulas. You need to know what those formulas stands for and how do you use them. And whenever you use a specific formula, you must always indicate that formula. You must write it down as it appears on the formula sheet. Don't make something the subject of the formula and substitute. You must indicate the formula that you are going to use. You get a mark for that. And then you must now substitute. You get a mark for that. And then you can work out the answer. You'll get a mark for that. So it is very important that you have this resource handy and familiarize yourselves about these formulas. When do I use this formula and when do I use a different formula? Okay, we're going to do some examples where we'll use these formulas. But remember, this is critically important to know what each and every quantity there means. If it says, for example, F net, what does F net mean? VF, what does VF mean? VI, what does VI mean? So that we are able to read the question and substitute the relevant and correct quantities in the formula. I hope we are together. It's very important that you understand this sheet. Okay, let's go for mechanics. Quantities. Doctor
Ali, yeah, before you go to that, yes, can you hear me now?
I can hear you, doctor.
Can you hear me?
Yes, yeah, I can hear you.
I was saying, before you go to that, I just want to make them aware of what we have just done now in relation to the definition, the tools, and the relationships between the quantities. If a learner looks at the tools and the relationships, this actually helps you to be able to define whatever that you are asked to define, and is also going to help to know the key ways that are needed to give you marks. So I just want them to use the 3 as the basis of what you are now going to be doing, so that they can see the relationship between the 3 that you have just done now, to help them to understand the physics in totality, because that's where the bases are. If they know these relationships between the quantities and they know the tools that are needed to be applied when they deal with these relationships, they will get the definitions easy. And again, you use the word knowing and understanding. If they're going to know which particular equation to use, that will be related to the definition that they are using in order to be able to answer the question. So that will go more with understanding. You know this, your understanding of the definition helps you now to solve all the questions that will be given. So I want you guys to be attentive as Bra Ali continues to then look at what is just alluded to now and see how best we can also apply those in answering the questions. Thank you, Bra Ali.
Thanks, Doctor. Thanks very much. You got it, learners. You got it. Right. Now, let's look at mechanics. In mechanics, we are given these relationships of quantities. Some of them are vector quantities, others are scalar quantities. I guess you still remember the difference between vectors and scalars. Because when you use these equations, when you solve the problems, we're dealing with vectors. You must handle vectors as vectors. That means they must have magnitude and they must also have direction. And if you deal with scalar quantities, you'll substitute them in the equation or in the formula that you use, and you don't have to worry about the direction. Now, when it comes to direction, the direction is derived from the Cartesian plane. Remember the Cartesian plane? Y positive, up, up, down, negative y, to the right, positive x, to the left, negative x. That is where the directions are derived, not north, south, east, and west. So, for example, if we have a certain displacement, x equals to minus 5 meters, that means x is a quantity, displacement, the magnitude is 5 meters, and the direction is minus. That means going to the left, minus in terms of the Cartesian plane. So the direction of vectors are as per Cartesian plane unless otherwise stated. Sometimes you can get a question where they say take up as negative or take down as positive. Other than that, I would advise you to use this plane to give us the guidance into which directions. Of course, you will not be penalized if you indicate that you prefer that down is positive. The only thing is that it might be confusing when you go to the other question and another question in another section. But nonetheless, the basis is that the direction of vectors, remember, we are talking about vectors. The direction of vectors, if it goes up, then the vectors will be positive. If it goes down, the vectors will be negative, except the acceleration g, which we'll talk about why it is always negative when we do the problems. Okay, maybe just to get that paper and pen ready and tell me that in line number 1, in row number 1, how many vectors can you identify? Just count the different vectors that you can identify in line number 1. You see line number 1? How many different types of vectors can you identify? Write it down. Line number 1, write down the number of vectors. And in line number 2, are you ready? Line number 2, indicate how many scalar quantities can you identify. The reason why we need to identify this is because when we use them in these formulas, those vectors, we must always take care of the direction. We must indicate direction positive or negative, and the scalar's direction does not matter. It does not have a direction. That is line number 2. How many vectors in line number 1? how many different types of vectors and how many different types of scalars in line number 2. Now I want us to go to line number 4. Please write line number 4. Which of those is neither a vector, or identify a number which is neither a vector nor scalar quantity in line number 4? Got it? Line number 6. Which of those quantities are constants? They are constants. Indicate the constants in line number 6. Okay, now let's have a look. If you look at line number 1, you'll realize that the final velocity, the initial velocity, the acceleration, change in displacement, x, that means along the horizontal, delta y along the vertical are vector quantities. So you have 1, 2, 3, 4, 5. Did you manage to get 5 different quantities there? Vector quantities. If you did, well done. So whenever you use those, they must either be positive or negative depending on their direction. Line number 2, there is only delta t, which is a scalar quantity. The 2 for 2a delta y, or vi plus v2 over 2, that is just a number. It's neither a vector nor a scalar quantity. It's just a number. The same goes for the number 3. You'll see that you have got your scalar quantities being mass. Number 4, mu s and mu k is just a number. It's neither a vector nor a scalar. When you multiply it with a vector, you just multiply. And in number 5, you'll see that delta t and m are scalar quantities. Number 6, which I gave you, you'll have the capital G and small letter g as your constants. Now, it is very important also to note that in the questions of work, energy, and power, we do not have vectors there. All of those are magnitudes only. That means they are scalar quantities. Your work, your gravitational potential energy, your kinetic potential energy, your power, all those are scalar quantities. So when you deal with energy, if you get a negative sign, it's just negative energy. It does not refer to the direction, because all those are scalar quantities. Okay, remember, why do we need to identify the vectors and scalars? Is because whenever we deal with vectors, we have to account for their direction. We have to indicate their direction. And there will be positive or negative, followed by the magnitude. Magnitude will be a number and an SI unit. Okay. In the given data sheet, you are not given these two that are in blue, but they're important. Just remember them. They are there when you are dealing with mechanics, that V is delta X over delta T, and V is delta Y over delta T. Remember, delta X means displacement along the horizontal or along the X plane, and the Y is along the Y plane or vertical. So it is important to note that, to remember this relationship, because we are going to use them again and again and again, especially when you deal with graphs. So you need to say the relationship between delta X over delta T will give us the velocity. The relationship between V multiplied by delta T, that means you make delta X the subject, the formula there will give you the displacement. Okay. Also, that A is delta V divided by delta T. Those three are also necessary. Just note them on your data sheet so that whenever you need this, you can go and access them. Okay, that is about the relationships of different quantities in mechanics. For example, the relationship between F net and acceleration is that F net equals to M multiplied by acceleration. You need to know what M stands for. You need to know what P stands for. You need to know what capital G stands for, and so on and so on. All right. Now, when we do electricity, we have a lot of formulas there, or a lot of relationships there that we will apply when we solve the equations of electricity. Again, you'll realize that in electricity, in electrostatics, we have vector F, which is electrostatic force, and vector E, which is electric field. When we deal with electric field and electric force, we need to indicate the direction because they are vectors. Other than that, all other formulas are scalar quantities. The only vectors in electricity, as per the formula sheet, is for the electric force and electric field. Other than that, everything else is either scalar or a number. For example, N equals to Q over E. That N is just but a number with no units. The rest will have units. Okay. Also, when it comes to line number 4, you are given R is V over I. You can make V the subject of the formula to get IR, or you can make I the subject of the formula to get V over R. That is very useful also to say the relationship between the resistance and voltage is that they're directly proportional. That means when one increases, the other one also increases. And the relationship between resistance and current is inversely proportional. That means when one increases, the other one decreases. But the relationship between V and I is directly proportional. V and R is directly proportional. So that proportionalities are important. That's why it is important just to, on the side, write those relationships. It is very, very helpful. When it comes to the waves, sound and light waves, you are given a set of equations that you are going to use. Now, in all those equations, there are only two vectors. VL and VS, the velocity of the listener and the velocity of the source. That is why in that formula you see plus minus. Plus minus, that means it's either in the plus direction or in the minus direction. The V is the speed of sound. So speed is a scalar quantity. Everything else will be scalar or constants except VL and VS. So it is important that when you use this formula, you know whether it will be V plus VL or V minus VL. And this is how we get the direction of VL, whether positive or negative. You take the Cartesian coordinates and you put the listener at the origin. Do you see the blue listener there? And the source away from the origin on the positive x-axis. Now, you'll be assessed when either the listener or the source moves, not both of them. Either the listener or the source moves. Now, let's have a situation where the source is moving. Do you see where you put the listener? And do you see where you put the source? Now, if the source is moving towards the listener, do you see that it will be moving in the negative direction? So your VS, velocity of the source, will be negative because it's towards the listener, which is towards the negative direction. If that source moves away from the listener, it moves in the positive direction, in the positive x direction. So your VS will be positive. The same goes when we have the listener moving now. The source is stationary, now the listener is moving. In which direction is the listener moving? Towards the source. So the VL will be positive because it's going in the positive x direction. Now, if the listener is moving away from the source, then it will be moving in the negative x direction, or it will be negative. So that is how we account for the positive or negative of the vector VL. Is the source moving towards the listener, that means in the negative direction, then that VS becomes negative. Is the listener moving away from the source, that would mean it's moving in the negative direction, that VL will be negative. So that is how, learners, you have to take care of the scalar quantities, the vector quantities, and in some equations you'll have numbers, and in some equations you'll have the constants. Are we together so far? Okay. Now, another tool that we're going to use. Remember, our first tool was the physical constants. Our second tools were the formulas, or the quantities, relations as per the formulas, wherein we have to take care of whether the quantity is a vector or scale. Now, the third tool that you will use in these questions or in this paper are the graphs. You will have straight line graphs and curved graphs. Now, let me start with straight line graphs. Do you remember in mathematics that a straight line graph is represented by y equals to mx plus c? You remember that? Where m is our slope of the graph and c is our y-intercept. Now, any graph, you put the independent variable or independent quantity on the x-axis, the dependent variable or dependent quantity on the y-axis. So the x-axis or the horizontal axis, that is where the independent variables are. The y is where the dependent variables are. Now, the line will have a slope. For example, the red line has a higher slope as compared to the green line. The slope can be positive, like in this case, and if you look at the second graph, the slope is negative. And what is the slope? The slope is m. And how do we get the slope? Opposite over adjacent. If you look at the third graph, it does not have any slope. That means the slope, the m there, will be 0, and our equation will be y equals to c. And if it is a negative, on the negative side, it will be y equals to negative c. So that is how we look at straight line graphs, and we can deduce the information. It's a tool that we can use to get information out of that graph. And there are many questions. Almost in every question, there will be one graph or the other. And graphs carry quite significant amount of marks. It could be about 6 or 7. So if you can master it, make sure that in each and every graph you get the maximum marks, already you will be making good inroads. If you take the concepts that you have to define, give you 20 marks, and then the graphs will give you another maybe 50 marks, and the other things will give you more marks. So this is how, when you look at a graph, you must say, oh, the other one is independent, the other one is dependent, and it does not matter what quantities you are using, it must follow y equals to mx plus c. That is a very important tool. Now, the slope is dependent over or divided by independent variable. That means the quotient. If you want to determine the slope, it's the dependent divided by the independent variable. For example, V equals delta x over delta t. That means if we have delta x as a dependent variable and delta t as an independent variable in a graph, the slope thereof will give us the velocity. Something divided by something, in this case, v is delta x over delta t. Now, we can determine the velocity from the slope of this graph. Or if we have a velocity time graph, the slope thereof, because it's something divided by something, delta v over delta t, the slope therefore will be acceleration. If we have delta p, that is momentum, and delta t, momentum time graph, where delta p is on the y-axis, delta t is on the x-axis, then the slope of such graph will give us the net force or the resultant force. From those equations, from those formulas, we can say, what is delta P over delta T? We look at those formulas, and if we have that, we'll find that that is the same as the net force. And how do we know this? By consulting our formula sheet and say, how is delta P and delta T, which quantities related to that? And we'll find that is F net. Or if you have work divided by delta T, that means work on the Y, delta T on the X, then the slope thereof, therefore, will give you power. You can be given a graph of W, work, and time, and the slope will give you power. The other important aspect of these graphs is the area under the graph. That means the area, as you remember, will be something multiplied by the dependent, multiplied by independent, multiplied by some value. That value can be 1, can be half, depending on the type of an area. So the product of these variables or these quantities, which we read from the graph, will give us the area. And that area is also associated with a specific quantity. For example, look at this. Look at that. AX is V multiplied by AT from that equation, from this equation. Okay. From this equation, you'll see that if you make AX the subject of the formula, you get that. So AX equals to VAT. We have that graph of V and T. Now we say if this is V and this is delta T here, then this area here will give us the displacement. How far has it been displaced? Okay. Now, if I go to the other one, let's see what happens if I use delta V equals to A delta T. That means the AT graph, the area below the graph will give us the velocity. So remember, the slope is something divided by something. The area is something multiplied by something. In the same way, if we have the graph of M mass and A, the area below that graph will give us the F net. If we have F and delta X graph, the area will give us work. Multiplied by a value, that value will be cosine of an angle. All right, so that is how we use the graph. Whether it is in electricity, whether it is in momentum, or in Newton's laws, or in projectile motion, just check what is the slope and if the area also will be important. For example, the area of force and T delta T will give you change in momentum. But where do we get this? Where do we get these quantities? How do we know about this, about that, about this? We get it from the formula sheet. On the formula sheet, you just relate F and A. It will give you that that indication will be given by the change in momentum. So change in momentum, if we have force time graph, will give you delta P. I really want you to understand this, because the graphs play a very important part in this examination, in this assessment. So don't get confused. When you see the graph, smile and say, I'm going to get some marks out of that, because I can determine the slope, or I can determine the slope and the area under the graph. Okay. So, okay, in electricity, the graph of force and charge will give you electric field. The slope will be electric field. Or in electricity, graph of V against I will give you the resistance. Because from the equations, you can get those relationships. From the formulas, you can get those relationships. Okay. Now, charge I and delta T will give you a charge according to the relationships. Let's look at this one. You are given a graph of velocity in meters per second and delta T in second. No. This graph is a straight line graph. We can determine the slope, which will be delta V over delta T. But what is delta V over delta T? Of course, we can also determine the area, which will be V multiplied by delta T, the area under a graph. Now, like any other graph, straight line graph, it is given by y equals to mx plus c. So we have that slope there. Okay. Now, if you look at it, what is our y on the y-axis? What is our y? Our y will be the velocity. You see that on the y-axis, y is the velocity. And what is our x? Our x is delta t. And what is our intercept? The intercept is there. Now, when it is there, that means is the velocity at t equals to 0. Remember, velocity at t equals to 0 is vi. Remember, it's initial velocity. Initial velocity is velocity when t equals to 0. Now, if we do that, you'll see that our v corresponds to y. AV delta V over delta T equals to M, and the C equals to the intercept. And in this case, the intercept is there at 12 meters per second, and the M will be delta V over delta T. Now, if we go and look at the equations of motion, and you'll see that delta V over delta T is the same as acceleration. So the acceleration is the same as delta V over delta T. That means the slope of this graph will give us the acceleration. But then we can also determine what VI is, because we can read VI as an intercept there. It will be 12 meters per second. Initially, this object was moving at 12 meters per second. So if we want to determine that delta V over delta T, it will be VF minus VI if we look at just until where V is 0. So it will be 0 minus 12 over 1.22 minus 0. The final time minus the initial time. And here you can now calculate. You'll get that your V is negative 9.8, which is the acceleration, and your initial velocity will be 12 meters per second. So we can deduce this information. If we are asked, what is the initial velocity? The graph tells us. What is the acceleration? The slope tells us. And we can also use the area under the graph, the green area in this case. Area of a triangle is half base times height is half V delta T. And so we can read it out that our V is from 0 to 12. That is our opposite, which is 12, multiplied by the adjacent. From there to there is 1.22. But because it's a triangle, multiply by half. And we can do that. And our delta Y change in displacement, or our displacement, will be 7.32 meters per second. So from this graph, we are able to deduce very important information. We are able to say this is the initial velocity, this is the acceleration, and this is how the displacement of this particular object, just from a graph. Okay. Now, let's take another example. We have another example here. Don't worry about the green part there. I wanted to remove it. It's what we drew previously. We have a graph of V in volt over I in amperes. That is potential difference of voltage and current. There is the graph. Now, what information can we get from this graph? You'll be asked information and say, what information can we get? Let's have a look. Remember, the slope and the area under the graph will give us information. The slope is V over I. Now, if you go to the equations or to the formulas and look for V divided by I, you'll realize that V divided by I is the resistance. So the slope of this graph will give us the resistance. How much resistance? We can just take any point. For example, let's say we want the slope using this dotted line. The opposite over the adjacent. Opposite is, each block is 1, 1, 1, 1, 1. If you look there, will be 1, 2, 3, 4. So the opposite is 4 units. What about the adjacent? 1, 2, 3, 4. It's also 4 units. So the slope is V over I, where V is 4 units. I is also 4 units. 4 divided by 4 will give us 1. And the units of resistance is an ohm. How did we know that it has to be resistance? By looking at the formulas that relate voltage and current. If we look at those formulas, we'll find the formula that says R equals to V divided by I. So the slope of this graph will be that. What about the area? If we take the area from 0 all the way to 8, is 8 units. that is the base, multiplied by the height, is 1, 2, 3, 4, 5, 6, 8 units. Is it 8? 1, 2, 3, 4, 5, 6, 7. Yes, it's 8 units. So it's 8 multiplied by 8. But because this area is a triangle, we must multiply it by half. Half base multiplied by height, and that area gives us 32 watts. If you take 8 multiplied by 8 divided by 2, you'll get power. How do we know that it has to be power? We go to the equations and ask and check what is the formula, which is V multiplied by I. And the V multiplied by I, it will tell you that it's power. Therefore, our slope will give us the resistance, and the area under that curve will give us the. Let's take another example. Let's take another example. Here's another example. We have a situation where we have acceleration as dependent variable and time as an independent variable. Now we want to check what is the slope here. The answer is we do not have a slope because that acceleration is constant. It's 9.8 at all times, so we don't have the slope. What about the area under the graph? It will be acceleration multiplied by change in time. Acceleration multiplied by change in time will be that area. And what will it give us? It will give us, it will give us A delta T. We go to our formulas again. We check and check and check and say, how is A related to T? You'll find that A is delta V over delta T. So that means A and T, if we make V the subject of the formula, V will be A multiplied by delta T. So this will give us the velocity of this particular object. I guess we are still together. Are we still on? Right. Now, let's have a look at another one. I'm using these various examples because in every question, there is a possibility that you'll get a graph. You need to be able to master how to deal with graphs, irrespective of what quantities you are dealing with. Let's take this one example. We have another one, V I, current is I, VI graph, and it has a negative slope. Can we determine that slope? Yes, we can determine that slope. Remember, it's a straight line graph. It can be given by, oh, by the way, in the question they say a student was performing an experiment and he came up with a graph given by V equals to negative Ri plus potential difference. They tell you that this graph is given by this relationship. We are told. Now, you must write this in terms of the straight line graph, y equals to mx plus c. What is in the y there? The y is the v. What about the x there? The horizontal is I. Therefore, the slope will be negative r, because you see it's a negative slope, and the intercept there will be the potential difference or the EMF. So the question is, for few marks, the question is, what is the EMF? Determine the EMF from the graph. You look at that relationship. So the EMF must be the y-intercept. You go with the graph. Where does it intercept the V? There. And you can read it. From there is 0.5, 1, 1.5, 2, 2.5. Therefore, your EMF, according to this graph, in terms of the straight line graph, your EMF will be 2.5 volts. You see, we are able to deduce the information from the graph. And the other question was, determine what the little r is, or the internal resistance is from this graph. You say, by the way, if I say y equals to mx plus c, so my m is the little r. I can go and determine the slope here. Remember, the slope is the y over x. We can determine using the whole graph. The y will be 2.5 according to this graph. The x will be 5. So it will be negative 2.5 over 5. And then we can quickly calculate and get what the value of little r is, or what the value of internal resistance is. Are we together? Are we still together, class? Okay. So that is how we use this tool called a graph to get other quantities. If it's a straight line graph, remember y equals to mx plus c, reduce it to that, and you will be able to get the right answers. Just these two questions, what is the little r and what is the EMF, give you 6 marks. So you see, it's easier to get information from the graph. Let's take the last example. I think you are following. Let's get the last example. You have a graph of force and displacement. Now, the slope of the graph will be force over displacement. You go and check in the formula what is force over displacement. What is force over displacement in the graph? Or the question could be, determine the work done by this object in such a way that it created this kind of graph. Now we say, how is work related to force and displacement? You check in the formulas and you find that force multiply displacement multiplied by a certain number will give you work. So the area under this graph will give you work. So you say length, which is 2, multiplied by height, which is 20, multiplied by half, which, because it's a triangle, multiplied by half is 2 times 20. So the work done up to 2 meters will be 20 joules. And then we can get the work done by the other section and the work done by the other section. Simply by getting the in this case, by getting the area under the graph, because the question says determine the work done. Now you say, how is work related to force and related to displacement? Okay, learners? Oh, I thought that was the last one. Okay, this is the last one. What I'm trying to emphasize is that in every question, from question number 1 up to question number 10, there will be graphs, and majority of those graphs are straight line graphs. We'll deal with those that are curved, but majority of those are straight line graphs. From straight line graphs, please determine what the slope is and determine what the the area is. For example, here we've got distance, delta x, and kinetic energy. Displacement varies with kinetic energy. And what will the slope give us? The slope is delta x over change in kinetic energy, delta x over delta ek. Delta x divided by delta ek. Now, you go and check on the formulas, and you realize that the slope of delta x over delta ek is an inverse of force, is 1 over force. So we can determine the slope. For example, we can say the slope is opposite 4.5 over adjacent 18. We say 4.5 over 18, then that slope will be 1 over f. Then we can determine what the force is. So that is how it goes, learners. That's how it goes. So we talked about the concepts that you have to know. 36 of them are prescribed. You have to state, not to know. You have to state, that means you must understand and know. And then all other concepts, relationships, are as per the tool called constants, physical constants, and the tool called formula sheet. Again, we said the tool that makes things easy also is the graph. Especially if it is a straight line graph, we can interpret any graph because we reduce it to y equals to mx plus c, and then we can deduce, we can get information from any of those graphs. Learners, let's take a 5 minutes break, stretch your legs a bit, and we are back at 11:20. Let's take a 5 minutes break and we'll be back at 11:20. Welcome back, everyone. Now that we dealt with the tools that we need to answer the questions for physical science paper 1, we can now go through each and every one of the 10 questions. Remember, the paper consists of 10 questions. First question is multiple choice questions. Now, let's have a look at it. So in the case of multiple choice question, remember, here you'll be assessed on all the aspects: mechanics, electricity, waves, all the questions, all the aspects that are covered in the paper. They want to know whether you have knowledge and understanding and the skill to deal with concepts and their applications, whether you can deal with the applications of laws and principles. So that is the purpose of question number 1. It carries 20 marks. Believe me, you need those 20 marks. They are important. It's 2 marks per question, and there are 10 questions. If you can get this 20 marks, at least 18 out of 20, and you get the graphs right in all the sections, and you get the define and the state, those 36 concepts right, already you have more than 75%, 75 marks. So that is one way of making sure that you get the marks. Okay. The MCQs, we have some few points here that I want us to look at. And Dr. Morf, is Dr. Morf?
Hey, Raleigh, I'm here.
Thank you very much. Perhaps I could request Dr. Morf just to run through these issues with your learners. What did you do when you handle the MCQs?
Okay, Bradley. Students, multiple choice questions are what we normally term the free marks. And how they become free, the first 3 sections that Mr. Letsoalo dealt with earlier on, they give you the best way of getting these questions correct. The first point here, it says that to improve your multiple choice test performance, start by reading the entire question and all options before selecting an answer. And as you read those questions and the details of what the question is asking you, you will then start eliminating. And in your elimination, you need to be able to give the reasons behind why are you eliminating those other options. So as you do that, this helps you to reason out and to also get the definitions, the tools that you are given, and the relationship of the quantities to help you to answer certain questions that will need you to use the formulas. And some of the questions that they'll want you to use the graphs, and you'll be able to do what you have shown, depending on what you are asked. If you use the graphs that have been discussed earlier on before we took the break, one of the things is the units, which are going to help you to see what is it that you are asked. For an example, you might be asked to choose the correct answer for gravitational acceleration, but this time not being given as meters per second squared as the units, but you are given that as meters per second per second. And different options that will relate that meters per second per second. It could be second divided by meters per second, or it can be your second squared divided by meters. All those, when you eliminate them, you'll eliminate them using the definition of acceleration, and you're also going to be using the units. And this, it is going to help you then to be able to see that you are going to integrate even the mathematics in that to help you to get the correct units, which will be meters per second per second. And as it said here, use the process of elimination to remove obviously incorrect choices, focusing on details like extreme wording. And these extreme wordings, the always and never, they might be more of giving you either the direction to see if there is relevancy or not. And the word always could be very dangerous because it might not be always that this will be the answer. That gives you an indication that you could see from the specific question that this is a distractor on its own. Never is also going to give you something similar to that. And you can also have a distractor like all of the above, none of the above. And all those, they are there to help to eliminate those that are irrelevant for this particular question. But again, focus on the details of the extreme wording that is being used, that is going to give you the direction. And again, make sure that if you are not sure about the answer and you have tried everything that you have just spoken about, you cannot come up with the final answer, we'll advise you to then say, finally, I'm going to play the lotto and I'm going to choose any, because in any case, I was not knowing what is the correct answer. I was going to get it wrong. Even if I get it wrong because I chose an incorrect answer, I've tried, but never leave the multiple choice question unanswered. When you play a lotto, you might win. If you play a lotto, I might win. And we can also be losers. So play the lotto because there are other questions. Consider skipping difficult questions to return to them later. So because you know and you have prepared, you read a question carefully, then you realize that I cannot answer this question. Then what I'm going to do is I'm going to start with questions that I'm sure of the answers. And as I collect marks on those questions that I'm sure of, my mind gets relaxed. The psychological nerve is then being reduced. And as it gets reduced, that difficult question that I thought it was difficult, it becomes also easy because now I can start relate because my mind is now relaxed, it's no longer panicking. So that is very important to read the questions, prioritize them according to how you are going to collect the maximum marks in the particular question. If each question is, say, let's say some of the questions, when you look at them, is 10 marks, 6 marks, 7 marks, you look at them and you say, out of 7, I'll be able to collect a minimum of 6. Out of 10, I will be able to collect a minimum of 40. And out of 6, I can actually collect the 6. My priority will start with the 6 and go to the 7-mark question. Then the 10th or the 10-mark question will be my third question that I'm going to answer, because the first 2, I've collected the maximum marks. in that particular question, then I go with the most minimum. And as I said earlier, that could be the question that I could actually improve from that 40% to either an 80 or 100%, because my mind will now be relaxed and been encouraged by the first two questions to answer with easy. Bra Ali, you can take over. I think I've done justice to the 3 points here. Bra Ali.
Thanks very much, Doctor. The
While you're waiting.
Doctor, thank you very much. The learners got it loud and clear. If I got it loud and clear, they must have got it even better. Thanks so much for that explanation. Indeed, check out the extreme wording. For example, you could get a statement like the normal force is always equals to the weight. The magnitude of the normal force is always equals to the weight. And you check whether that always really is the case. So those are some of the indications that he explained could be helpful. Okay, thank you very much. Now, let's have a look at some of the issues that are important. Some of the issues that are important here are that, in summary, you must read the directions carefully. Make sure that you understand what is being asked. Don't rush to answer the question without understanding what the question requires. Take your time, read it, even if you have to read it again and again, so that you are sure what is being asked. You must read the entire question and all answer choices before selecting the answer. That is what Doctor has emphasized, Dr. Molefe emphasized that. Okay, and then that will assist. I think Doctor has covered them significantly. Always look for the best or the most correct answer. Some answers can be very close. Try to get the best or correct answer. Okay, so that I'm just summarizing what Dr. Molefe has indicated, and then make sure that you pay attention to grammar. The correct answer will often be grammatically consistent with the question, so the grammar also helps there. Okay, now let's take an example. Let's take some few examples. You are given an object. It moves along a smooth surface or frictionless surface, and then you are required to compare the magnitudes of forces acting on the object. What are the forces acting on the object? In particular, the normal force with respect to the other forces. Number A says the normal force will be the same as the weight, Fg. Number B says the normal force will not be equal to the weight, but will be greater than the weight. Number C, the normal force and the applied force in this case will be equal, will always be equal. Number D, the normal force is less than the weight. Now, you see, we've got some options. In this particular instance, it will be, don't just thumbsuck the answer. Draw a free body diagram, label your forces, which one is the normal force, which one is the weight, and which one is the applied force. And remember that, that's something I forgot to mention when we were dealing with vectors, that because we use the Cartesian plane as our reference for directions, any vector which is not along the x, which is not horizontal or vertical along the y, must be resolved into its horizontal and vertical components. That is why the FA here is resolved into horizontal and vertical component. Once you do that, you don't draw that vector FA. Now, if you look at this, then you can easily deduce that, okay, n plus another force equals to the weight. That means, remember the n, I hope I'll get the annotator. The n is this one. Remember, the normal force is always perpendicular to the surface, and it's a surface force. And this is the component of A. FA, sorry about my handwriting. FA perpendicular, and this is FA parallel. And this is FG. Now, from this picture, then you can see that the A will not be correct because N, the magnitude, remember, the magnitude going up the N will not be the same as the magnitude of FG because N plus FA perpendicular equals to the FG. What goes up is the same as what goes down. They're balanced in that direction. So number A, you eliminate. Number B, Fn is greater than Fg. Look again at your sketch and say n plus something equals to Fg. So Fg will be greater than n because n up plus something which is not zero up equals to something that goes down. So Fg will not be, Fn will not be greater than Fg. Fn equals to Fa, again in magnitude, you can eliminate that. And so it leaves number D as the correct answer. So that's how you eliminate this situation. Let's have a look at the other question. They say the net forces acting on the object is Fn. Do you think Fn, the normal, will be the net force? No, it will not be the net force because there are other forces opposite direction, and because this block is not sinking into the ground or flying away from the ground, the forces around the horizontal, the vertical, are balanced in terms of Newton's first law. Number B, Fa equals, the net force equals to half of Fa. Again, remember, Fa parallel will be the net force, isn't it? Fa parallel, isn't there nothing that opposes Fa parallel? So this will be the net force. This will be the net force. Now, but what is this net force? It's Fa cosine of 60 degrees. Now, cosine of 60 degrees is half, so the net force will be FA cosine of 60 degrees, because the net force will not be that. That will not be the resultant, because there are other forces in other directions. And Fg cannot be the net force because it's not sinking down. Remember, the net force, the object will move in the direction of the net force. So it's not sinking into the ground. And as a result, that is not part of it. Doctor?
Before you erase that, can you go to the first sketch where you've got the 60 degrees there? For the sake of learners, it will be prudent for them to complete that diagram like you alluded earlier. They must have their X component and Y component on that. Good. And that it will be then that FA parallel.
Yes. Did I put cos theta here?
Yes, you can put it that way, it's fine. That's correct.
And another one this side.
Let's put it on the other side, Bra Ali, for the sake of peace.
Okay.
Yes, put it there. Great.
That's right.
Yes. Then we say, if you have the right angle triangle, you can actually now use your trigonometrical ratios to help you to find out where does the FA cosine of theta comes from and where does the FA, the sine of theta, comes from. Because if you are using the sine or a SOHCAHTOA from mathematics, then it will say the sine of the 60 degrees or theta is equals to the opposite side over the hypotenuse. And in this instance, the hypotenuse is the FA.
Yes.
Then as you make the the Y component the subject of the formula, and this goes back to what it was discussed earlier when we were looking at the quantities that are given and how to use the tools. Then as you make that the subject of the formula, then you see where the FA, the sine of theta, comes from, and the FA cosine of theta comes from. Now, the diagram that is drawn below, it results from the one that has been completed there and been drawn with all the vectors then labeled. And then the below one, where we have the N and you have the FA parallel perpendicular and the negative FG. This results from that diagram there. And then it helps you to reason out why your answer for this first part was D and why the second one, the answer is B. The reason that I wanted this to be completed is because it helps us now to understand the F perpendicular and the F parallel. Where are they coming from? Is the result of this right angle triangle that has been drawn. And because of the understanding of the sum of the vectors, because we sum the vectors.
Yes.
And as we sum them, we have seen that the vertical components, they balance. But the horizontal, we only have one force, which is FA parallel. And that FA parallel is equals to the FA cosine of theta. Then that helps you to eliminate and comes with the final answer. Thank you, Bra Ali.
Thank you very much. Thank you very much, Doctor. You got it, learners. Remember, any vector which is not horizontal or vertical is at an angle, it must be resolved into its components. And Doctor indicated it clearly how to get the FAs and the F parallels and the F series. Thanks very much. I'm trying to rub off this. Okay, now let's take another example. Let's take another example. I'm just rubbing off this because it will appear on my next example. Okay, now remember multiple choice runs across the topics. In the same question, question one, you can get an electricity question, which says you have this circuit and the switch is closed. Now relate the voltages F1, V1, V2, V3, V4, and indicate which one is correct. Use the system of elimination. Here, remember, because you are dealing with voltage and resistance, you see, we've got resistors there, resistors R. We're dealing with voltages and resistance. You must now go and say, what is the relationship between the voltage and resistance? How do they relate? When do we have voltage and resistance being more or less depending on the situation? So you go there, you visit the relationships, and you'll realize that V and R are directly proportional. That means where there is more R, there will be more V. And then now you can look at the diagram. Then the other thing is that whenever you deal with electric circuits, you must identify which resistors are in parallel and which resistors are in series, and the implication thereof. What is the difference between parallel resistors, the sum of the parallel resistors? How does it differ from the sum of series resistors in terms of resistance? Now, if you look at the formula sheet, it will tell you that the resistors in parallel tend to, if you add them, the resultant resistance will be less than the least of those resistors. Well, let's make an example. Take a pen and paper quickly, learners. If we have two resistors in parallel, each resistor is 10 ohms, and two resistors in series, each resistor is 10 ohms. What will be the total resistance of the series connected resistors, 10, and what will be the total resistance of the parallel connected resistors, 10 in parallel, 10 in series? Can you quickly work it out? Got it. So the ones in series, it will be 10 in ohms plus 10 ohm. Which will then give you 20 ohms. Oh, sorry about that. And in parallel, it will be 1 over total resistance Remember, we want total resistance, not 1 over total resistance. Learners tend to end up at 1 over total resistance, will be 1 over 10. Let me leave the units for now. but we have to write them, plus 1 over 10 which will give us 10 over 2, which will give us, 2 over 10, and the RT, total resistance. No, I'm not, am I doing it correctly? 1 over 10, 1 over 10, the LCM is 10, will be, yes, 10 over 2. Then this will give us 5 ohms. Now, from that relationship, you see that the ones connected in parallel will have less resistance, even lesser than the minimum resistance of each. And the one that is connected in series will have, or the one that is connected in series will have more resistance. So voltage is proportional to resistance. Now let's look at the options. V1 equals to V4. V1 is R. V4 is across smaller resistance, because when we add them, we get something less, isn't it? So V4 will be resistance for less, resistance, less resistance from 2 parallel resistors. So this will be less. So V4 will be less than V1 because this one is R. This one will be less than R. So V1 equals to V4, you eliminate. Because V4 is for the less resistance, it must have, the value must be less. V1 is less than V4. V1, the resistor here is higher, here is lower. So lower resistance, less voltage. So this one also we eliminate. Now, V1 equals to V2. V1 equals to V2. Do you see that V2 and V4 are equal? Because across parallel connectors, voltage is the same. So V2 and V3 and V4 are equal. So when we say V1 equals to V2, we mean voltage on a higher resistor equals to voltage on a lower resistor. So that one also falls off. And the last one, V1 is greater than V4. The resistance here is higher than here. So V1, because it's across a higher resistance, must be more than V4 across a lower resistance. So that will be correct. The last one will be correct. That is how, as Dr. Molefe indicated, you read the question and you apply the relationships, and from those relationships, we are able to get the right answer. Okay, that is how we approach the multiple choice questions. Let me cancel this. Okay, so that was just to give you an idea. It's just to summarize what Dr. Mlefe explained about the elimination, reading the question properly, take a guess, but apply the principles, apply the laws. Look what relationships are there and work on those. All right. Just a moment. Okay. Look at this one. A constant net force, that is in mechanics, constant net force. So we are not only talking about an ordinary force, we are talking about net force. Is applied to a block. Which one? You see, the one is in capital letter, is stressed. Which one of the following statement is correct? You want a correct statement. There is a net force. From Newton's second law, net force is equals to the mass of the block multiplied by its acceleration. And the movement is in the direction of motion. So you can hear the net force. We are talking about the mass. We are talking about the acceleration. Now, the question says, which one statement is correct? The block will move with a constant velocity. Net force brings about constant velocity. You check. When do we have constant velocity? When the net force is 0 newtons. So that will be eliminated. Number B, constant acceleration. The net force is constant. And what is the relationship between net force and acceleration? Directly proportional. So constant acceleration, at least, yeah, we are talking. It's something that we can consider. But remember what Dr. Molefe said you must read all the options. Don't just see, oh, there is acceleration here, so that must be correct. Okay, we are saying this is something that we can have a look at. Constantly increasing acceleration. You see, the word increasing, if the net force is constant, the acceleration will be m multiplied by constant acceleration. It don't increase. So this word makes us to eliminate this one. Constant decreasing acceleration. Again, the word decreasing, because the net force is constant, meaning that acceleration must also be constant. So we'll eliminate that one. By the way, remember, the net force has got nothing to do with velocity. It has something to do with acceleration. We eliminate that one. Then, after elimination, this will be the most correct one. The others have issues. You see, that is how we deal with multiple choice.
Ali, can I come in on this one quickly?
Yes, Doctor.
Going back to the quantities that are given, those equations of motions that are given, we said that those equations are only valid if the acceleration is constant.
Yes, that's a very important point.
That also helps you to eliminate the last two, because for you to get that acceleration or that object that is having a constant net force, it means that acceleration that is going to give you that object to be in motion, that will be related to giving you the constant acceleration, and the equations of motion are.
Thanks very much. It's a very important point. I think I didn't stress that point when we're dealing with the quantities. Remember, I just want to reiterate what the doctor said. All those equations are only valid if acceleration is constant. That means the moment we have acceleration which is not constant, the object will not move in a straight line. will not be a linear motion. Because we are dealing with linear motion, either horizontal or vertical, the acceleration is constant. The velocity may be constant, the velocity may change, but the acceleration remain constant. Okay, so we got this information from this statement about what the net force is, and that the net force is directly proportional to the acceleration, assuming and knowing that the acceleration is always constant. So that is how, from the tools, we are able to do that. Let me, before I go to the next example, let's have a look at an object that is thrown vertically upwards. We have an object. We are going to deal with projectile motion later, but I think this is important just to note it here. An object is thrown vertically upwards. It goes like this, zing, and then it comes back, zing. Maybe it comes back to a different level. It doesn't matter. Now, what happens to the magnitude of the gravitational acceleration when it goes up, while it is going upwards? How is that magnitude compared to this gravitational acceleration at the highest point? Remember, at the highest point, our V is 0. What will happen to the magnitude at the highest point? And what will happen to the magnitude of this when it comes down, of this V, gravitational acceleration, when it comes down? Will there be any difference in terms of the magnitude of G? Yes or no? I remember this question was asked in one of the question papers. They wanted to know, when this moves upwards, the velocity decreases. When it moves downwards, the velocity increases. At the maximum point, the velocity is 0. What happens to G? Does it change when the velocity increases, when the velocity decreases, and when velocity is 0 at the maximum height? The answer is that the magnitude of G remains, whether it's moving upwards or downwards, or that moment when V equals to 0. Remember, the velocity is change in, acceleration is change in velocity. Acceleration is not velocity, it's change in velocity with time. So it will change from something, let's say 10 meters per second and up to 0. So the change there is 10. Not that because it's 0 at that point, velocity, the acceleration will be 0 there. The same goes for the direction. Whether it's moving upwards or moving downwards, the acceleration remains in this direction, which is in the negative direction. If we take the Cartesian plane as our reference, if we take down as negative. So G does not change direction even when the motion changes direction. This is because when this object goes up, change in velocity is from lower to high. Remember, when it goes up, it reduces, the velocity decreases. So it's from a lower value to a higher value, which will be negative, divided by time. Whereas when it comes down, change in velocity, because now the velocity is increasing downwards, it will be a high negative minus less negative. So that is why it remains negative, whether it's going up or it's coming down. Okay. Now, we are still dealing with multiple choice. The interesting thing about multiple choice is that you easily get marks there. All you have to do is just apply the relationships, apply the definitions of concepts, like in this case, the net force. What is net force? And using the relationships, you are able to answer the questions and get most out of the question paper. And secondly, the good thing about question number 1 is that it covers all the areas. So if you have read all the areas, it is easier for you to answer the relevant questions. Okay, that takes care of that example. Now, I'm aware that the example, time is not very much on our side, but we'll get there. We'll get there. So number B is correct. Let's look at just one more time. One more. You have, because this also helps us to summarize the next questions. You know, if we dealt with here, it's easy to run through the questions on Newton's laws and so on and so on. A crane of mass M is stationary on a plane incline at an angle theta with the horizontal. That crane is not moving. And the word is stationary imply that we use Newton's law, because Newton's law says if the application, if the object is stationary, then forces exerted on it are balanced. That means the forces up the incline and the forces down the incline in direction are equal. The forces perpendicular to the incline and the other way around are equal in magnitude but opposite in direction. Now the question says, which one of the following statements regarding the magnitude of the frictional force acting on the crane is correct? Again, remember what you were advised, read all the options and start eliminating. Now, the magnitude of the frictional force acting on the crane is, we talk about frictional force. So it is best to draw a free body diagram of all the forces so that you can be able to look at what that implies. So we have got the force there, we've got the force there, we've got the force there. This one is not along the X and Y. Remember, we take X and Y with respect to the inclined plane. And so you draw all your forces, and therefore, the frictional force is pulling it there and is opposed by this component of the weight, that is FG parallel. May I just indicate that in this case, when we have an incline, our plane is like this, where this will be our X, and this will be our Y. So the plane is parallel and perpendicular to that. So that is why this weight, or FG, we must resolve it into components. Which component? F perpendicular, FG perpendicular, and FG parallel. So,
Ali,
Doctor,
yeah, you have labeled them wrongly.
Sorry, yes. This
You are
must
saying
be
the correct thing, but you are writing the wrong thing.
FG parallel and FG perpendicular. Thanks, Doctor. So the FG parallel equals to the F friction. I think it's FF, yeah, something like that. So that is the case. So looking at the options, the first one says the magnitude of the frictional force acting on the crate is equal to the component of the weight of the crate which is parallel to the plane. Remember, this is in the positive direction, that is in the negative direction. Positive x, negative x. So they must be equal because it's not moving, they are balanced. So that number one is correct. And if you look at the rest, you'll see that there are some errors in them. So there we are, learners. That is how we deal with question number one, which is multiple choice, MCQ. I just want to indicate that try to maximize your marks by making sure that you do well in this particular section. Newton's laws is question number two. Now, Newton's laws is about forces. It's about forces. And we must just note that when the object is moving with constant velocity, or when the object is at rest, forces are balanced. Newton's first law. When the object is accelerating, uniform acceleration, Newton's second law, forces are not balanced. There is a net force in the direction of motion. And that net force equals to the mass of the object multiplied by that acceleration. Remember, mass is a scalar and acceleration is a vector. The direction of the force will be the same as the direction of acceleration. So you have quite a number of possibilities. In one situation, you'll have a horizontal plane like that. The object is there. It might be pulled in that direction. And if we are told that it is at rest or is moving with constant velocity, then the forces are balanced. Like we said, if the force is not along the X or Y, or it's not vertical or horizontal, that must be resolved into FA parallel and FA perpendicular. After resolving it, you cancel it out so that it doesn't confuse you. Now, the friction will be in that direction. The weight will be in that direction. The forces in the Y are the same, have the same magnitude as the force in the negative Y. The forces in the positive X have the same magnitude as the forces in the negative X. The same can be put on an incline. Again, you must just resolve the forces and create a free body diagram. So in this case, we have got two forces which are not along the X and Y. This and that must be resolved. And if it is at rest or moving with a constant velocity, they are balanced. If they're not moving constant velocity, and we say they're moving, this one is moving in that direction, is accelerating that direction, that means this force here is more than the force in the opposite. It should be the bigger force minus the smaller force equals to mass times acceleration. So whatever combinations of objects that you are given, remember you deal with one object at a time and draw the free body diagram for that. That will then be able to give you the necessary answer. But please don't forget to resolve the forces which are not along the X and are not along the Y into their components. And after doing that, you must remove the original force, which is not along the X and along the Y, you remove that. So those will be the forces. Of course, there will be a normal force here. There will be a normal force there. This must be like that. Doctor? And like that.
I just want to jump in here
Yes,
with
doctor.
one of the multiple choice questions that you had, or the three that you actually said we can follow as how to answer the multiple choice.
Yeah.
Where we said we must zoom in into the words that are used, words like
Yeah.
always and never.
Yes.
This is a typical example of how you see those words are not related to answering the question. The first diagram that we have shown, it gives us the normal force and the weight to be equal.
Yes.
But on an inclined, they are not. The very
Yes.
same diagram that we have just drawn, Ali. Go
This
back
one.
to that next slide. These two. I want to use both of them.
Okay. All right.
That's right. The one on the left. Yes. The normal force and the weight are equal.
Yes.
But that does not mean that they're always equal.
Equal. Yes. Oh, yes. Yes.
When you go to the inclined, the normal force is not equals to the weight.
Yes. Yes.
Is the component of that weight that is equals to the normal. So hence we said you must look at those weights, the always and never, because the always is misleading when you have this diagram that is an incline. Thank you, Brali.
Thanks, Dr. Moff. So that was just in summary. Look at the laws and apply them accordingly. Is it accelerating? Apply Newton's second law. One force will be greater than the other or will be the only one. And is it moving with constant velocity? Newton's first law. Constant acceleration? Newton's second law. Is it at rest? Newton's first law. Forces are balanced. Is it moving from rest and attain a different velocity? Then you will have all those other situations. Just to summarize the whole thing, you'll be given things on the incline like that, and some will not be on the incline, will be on horizontal surface, others will be on the vertical surface. All you have to do, identify the four different type of forces. Remember, it can be applied or tension, it can be weight, it can be normal, it can be friction. Now, depending on what we are given, let's just take, for example, this one. If you are given, okay, this one is the one that we made an example with. After drawing all this, ask yourself, is it at rest or is it moving with constant velocity? If it is at rest or moving with constant velocity, the forces on the horizontal in the positive direction will be equal to the forces in the negative direction in magnitude. The force to the left will be equal to the force to the right in magnitude. So the forces are balanced. If they say it's accelerating to the right, that means in the x direction or in the positive direction, then the FAX minus FF will equal to MA. So that is how you will then use Newton's second law to say the bigger force minus the smaller force equals to M multiplied by A. If, for example, this situation is accelerating but to the left, so FF minus FA equals to MA. If it is on the incline, the difference is that in this case, the weight must be resolved into its component. If it is at rest, what goes down the slope in magnitude is the same as those that are pointing up the slope in magnitude because they are balanced. What is perpendicular up or down will be the same. But if, for example, it's accelerating upwards, then the force in the direction of motion will be minus the forces in the opposite direction. In this case, for example, let's say it's accelerating down the slope. It's accelerating in that direction. Then we are not worried. We say the forces are not balanced horizontally along the plane. So FG parallel plus FA, those are the ones that are going down, minus FF will be equal to M multiplied by A, because second law says the total, the net, the resultant equals to MA. So yeah, so that is how always just resolve that into those that are not along the X and Y into components, draw the free body diagram. Remember, when you do the free body diagram, you need to make sure that the arrows touches the line. The examiners don't take an arrow like this. If you draw an arrow like that, you get penalized. So the arrows must always touch the line. Okay.
Bra Ali.
Dr. Morse.
Bra Ali. Yes. Let's go back to that F net in any, which is equals to MA.
Yes.
Down the way you have written now, you are parallel and perpendicular. Any or the horizontal is fine. Yes.
Okay.
Learners, you can see that here we say F net is equals to MA, and the statement below, it does not necessarily say FA minus the FA in the X minus the F of frictional force, but it says that FA plus a negative frictional force.
Yes.
And this is what we are saying to you, that the F net is actually giving you the sum of all the forces that are acting on that particular object in the specific direction. So we never subtract the vectors, we sum the vectors. Then the negative sign and positive signs will deal with themselves mathematically. But from the physics point of view, with vectors, we sum them and we take the vector with its sign, like the ones that are inside the bracket. Because they are negative, they come with their signs, but they're added to other forces that are in the same direction. Thank you, Bra Ali.
Thank you so much. May I just highlight remember when we talked about the formulas, we said you must always identify the vectors. Because forces are vectors, the net force is the sum of all the forces. The sum, that means plus. plus, 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 plus. But when you write them, for example, FF is this one. Do you see FF here? Is pointing in the negative X direction. That's why we put that negative there, because it's a vector. We say FA plus another force, but that force is in the negative direction. So it is very, very important to always be conscious of the negative, the vector nature of certain quantities. Okay. Okay, let's take another example here. It is important to be aware of the law that it's applied under the circumstances given, and it's important to draw a good free body diagram, because if you do that, then the rest falls into place. Okay. Well, this is just another example where we did this example. Now, I wanted us to look at the kind of situation where things are having tension between them. That means are connected in such a way that we have tension between them. Look at this one. It's a typical question. We have got 2 or 3 blocks in this case, the one on the table and 2 that are hanging. Now, whenever you have this kind of a situation, remember to have the free body diagram for each one. You look at the first object, draw a free body diagram. Then you go to the next object, draw a free body diagram. Then you go to the next object, draw a free body diagram. Now you ask yourself, is this situation at rest or moving with constant velocity so that we can have the forces balanced, or is it accelerating? If it is accelerating, the force in the direction of motion will be more than the force in the opposite direction in terms of magnitude. Then you sum up the forces accordingly. Let's take this as an example. We have this object, the first object. The free body diagram for the first object will be this. It's on a surface and it's being pulled, whether it's moving or not moving, it's being pulled by Ft1. Do you see that? Ft1 is pulling it in the positive X. And the friction, because friction always opposes motion, will be in the negative direction. And the normal, again, is perpendicular, and Fg is perpendicular downwards. Now, if this is at rest or is moving with constant velocity, then the sum of the forces, that means F plus Ft1 will be equals to 0. Therefore, Ft1 in magnitude will be the same as Ff. The same goes for Fn and Fg. But now, what about if we say it accelerates in that direction? The 2 blocks are really pulling it and it accelerates in that direction. Then in that case, Ft1 plus negative Ff will be equals to mass times acceleration. Then you go to the next one. The next one is this one. It has weight, Fg, but is being pulled by this other one with force Ft2. So the 2 forces, Fg and Ft2, are in the negative direction. What is the other force? Pulling it. Remember, tension is always a pulling force. It's never a pushing force. So as far as this body is concerned, it is being pulled, even if it is accelerating this way, but it's being pulled upwards. So it will be Ft1 pulling it upwards equals to the ones that are pulling it downwards. If it is at rest, then the forces Ft1 plus Fg plus Ft2 will be equals to 0. But Fg and Ft2 will be negative, negative. So we write it in terms of its negativeness. The last one, this last one here is being pulled by its weight and is being pulled by the tension. Remember, tension, even if it goes down, it's never a pushing force. So the free body diagram will be Ft2 and Fg2 in that direction. Again, you ask yourself, which law must I apply? First law or second law? So that is how in this chapter you deal with this kind of situations. You could be given a graph, you know how to handle the graphs. You handle the graphs like the examples that we did previously. Okay. All right, let's move on. Let's move on to the next chapter, the next question, the projectile motion. Again, this is another easy section or easy question. Actually, all of them are not difficult. Just that you apply the principles, apply the laws, use the tools that we talked about. So if you apply those tools, you can actually handle any of the questions indicated. In this instance, things are moving vertically up or vertically downwards or vertically up and down. You could have something here that moves vertically up and it comes down to the same level, or it can go vertically up and it goes down below the original. Maybe this is a building, and then it goes up and goes right down. Or you can have an object that is thrown vertically downwards, maybe just let go, free fall, where the initial velocity Vi is 0 meters per second. Let me not write meters. My pen is not very friendly. Per second. Or it can go down, thrown with a certain velocity Vi, which is not 0, meters per second. Or it can be released from a lift or from a balloon. Here is a lift or a balloon moving up with velocity V. The velocity of the balloon is Vi and dropped. So in this case, it's the same as it will move up and then come down. It's the same as that one. So in all these cases, we must just remember that the only force acting on this object, if we draw the free body diagram, will be Fg. That's the only force acting on the object, Fg. Otherwise, if there are other forces, it will not be free fall or projectile. When you have birds flying or aeroplane flying, they are not in free fall or in projectile. So the only force is Fg. Therefore, if we go to the equations of motion, we have got 4 equations of motion that we are given, and every time we come up with acceleration, we must remember that is Fg. So we have these equations, 1, 2, 3, 4. We use the ones with the y because we are moving along the y. We're using the ones that has the y. Vi equals to Vf equals to Vi plus A delta T. This is number 2, that number 3, and that is number 4. And you let's take an example. That is an object moving vertically upwards or vertically downwards, and the influence is gravity only, is called a projectile motion. Remember some few points here. Let me rub off this unnecessary things. Remember some few points here. When we deal with projectile motion, it's either moving up in the positive direction or moving down in the negative direction. The acceleration from those formulas, A has magnitude 9.8 in the direction negative. And so the velocity is decreasing when it goes up. That is why acceleration becomes negative. The kinetic energy will decrease because the velocity is decreasing. Gravitational potential energy will increase because the height is increasing. So those are important to note so that when you deal, sometimes they will say use energy consideration. Then you'll check what happens to the kinetic energy and what happens to the potential energy. So that is how we deal with it. I want us to take just one example and move to the next question. Right. So this object is moving vertically upwards, is given the initial velocity, we say it moves, initially is given 29 meters per second. I always prefer to put the quantities in a table because it helps us see what is missing and which equation can we use. So we are given the initial velocity up to the maximum height. At maximum height, know that the velocity will be 0 meters per second. And the G is negative 9.8. We have 3 quantities. We can always solve for the 4th one. We go and look at the equations. We go and look at our equations here. 1, 2, 3, 4 equations. One of these equations should be suitable. We have all those quantities available. So that equation is the one that we'll use because we have got VI, we have got VF, we have got G, because we want to calculate delta Y. So this equation is the one that we'll use. Always write the equation. You get a mark for that. Or write the formula, you get a mark for that. Then substitute, you get a mark for that. Then solve and make something the subject of the formula and get an answer, you get a mark for that. So for writing the equation, for substituting, and for getting the marks, getting the answer, you get the mark for that. So whenever, it does not matter what type of vertical projectile motion is, have a table, write down what you need, and what you know, use a specific equation and solve. And in that case, you get a mark, even if you don't reach the answer, but at least you shall have covered the marks. Now, the second question says we want to determine time. That means we want to know what time, when did it reach the maximum height? Again, in this case, you are given, you know those 3. Now, there must be an equation that has VI, VF, and G, and that equation is this one. You write down the equation. You substitute. and then you solve. So we make T the subject of the formula, and you get the answer. Now, another example, the question is, calculate the time it will reach the same place it started. It went zing, zing. Now, the time to reach the same place, again, you say, what is it that I know? You have a table of what you know. You are given that the VI is given, the G is known, but then if it starts here and it ends up here, then the displacement will be known. You go and look for an equation that has Y, Vy, and G because you want time. You see, you don't use the Vy equals to 0 because we are not interested now at the maximum height. We say, when will it be back where it started? Then the Y will be 0. For argument's sake, if this went up and missed the trampoline and come and fall to the ground, then the displacement will be this Y here. Because that one is vertically upward, is a vector, and up to there is another vector. When we add them, it's like adding 2 plus -2 is 0. So the remaining displacement will be that one, and it will be in the negative direction because it will be falling in that direction. So if this is the case, it will be negative something, negative Y here, whatever you are given the height of the trampoline. So that is how we deal with projectile motion. They'll ask the question like, how high, at what time will it be at maximum height, when will it be back on the ground, and so on and so on. Okay, so the time is not on our side, but let's complete that. So this is question number 3. Again, it's not a difficult question. Remember, you use the 4 equations and have a table of the information you need, choose the right equation, substitute, make the subject the formula, solve, get the answer. All right. Now, again, on this one, you'll be asked about graphs sometimes. You'll be asked about graphs sometimes, and this is how you deal with it. The position time graph will be a curved graph like that. This is positive, down is negative. It starts, it goes up with relative to time. The x-axis is time. It will take a bell shape like that. Where it ends, that will be the maximum height. And if you need velocity time graph, it will be a straight line. Actually, the one that we used as an example, the other side. It will be a straight line like that. That means it started with high velocity. That is the initial velocity. It started with high velocity. It slowed down until it reached the maximum height. This corresponds to the maximum height. So the time here is the time to reach the maximum height. They will give you, let's say they say this is 5 seconds. They say, when will it reach the maximum height? We can get it from the graph. This is the VI. This is the velocity at the maximum height is 0. The time to reach the maximum height. And what happens after that? The velocity increases, it was 0. It increases in the negative direction. So the time, perhaps it reached the ground here, the time T2 to reach the ground will be that one. And how high will it go? Oh, the area between when it was projected and when it is at the maximum height, that is how high it will go. And what will be how low will it go before it reaches the ground? That will be this other area. And the acceleration time graph will just be a straight line. And the area, remember we did an example, the area here will give us the velocity with which it reached the ground. And in the event where there is bouncing, sometimes they ask questions about bouncing. In the event where it bounces, this from here, it will bounce maybe up to there. Maybe it will bounce again up to there. And every time you can read how high did it go when it bounced, how high did it go when it bounced. And in the case of the velocity time graph, it reached the ground here. Now it bounces with a certain velocity. It will be something like that. But I have better graphs there. I just wanted to quickly indicate what happens when things bounces. Let's have a look at another example. Yes, another example where it bounces. My board is a bit, it has many things. Let me remove them. Look at this one. You are given that the height of the building is so much, is projected upwards to maximum height of so much. It comes down and it bounces to a height of P. Now, the question is, what is VI? Again, you know the Y, you know the G, you know the maximum height, you can get the VI. As long as you have three quantities, one equation will make it possible to get VI. This equation here will make you calculate what VI is. Because you know from where it was projected with velocity VI, you know how high it went. There it is given. And at the maximum height, you know that V equal to 0. There is the second one you know. And the G is always known. Substitute, then you get your VI. The next question was calculate the lost EK. Now, determine the energy there. Mechanical energy is conserved. To use that principle that EP plus EK equals to the mechanical energy and is constant. It's the same there and it's the same there. So you use that principle. And that is how you go about it. Half mv squared, because remember mgh is the m, the g we know, the h will be that displacement there. Now, time to reach point P after leaving the ground, if it leaves the ground at 11.92 seconds, you know VI here, maximum height, you know V, you know G, you can easily calculate the time that you need. So just make sure that you get three quantities, solve for the fourth quantity. Sometimes you might be given a graph like this one. They say determine the initial velocity. We have just calculated it there. What is the initial velocity? When will it reach the maximum height? We have calculated somewhere. And here is when will it reach the ground. So every time you can identify those points from the graph or from the given quantities as it is now. We are left with few minutes. Can you believe that? Let me leave this one. The idea here is try to get 3 quantities, solve for the 4th one, make sure that the direction up is positive for all vectors except G, because G is always negative. And if we have the graphs, you can read the information from that graph like we did when we handled the graph.
Ali.
Ta.
Yes, I just want to emphasize that what we said earlier, that they must read the question and to understand what the question wants. This question is so specific that it wants them to use the equations of motion.
Yes.
That's question A. So if they read the question and say use equations of motion, you are not going to use any other methods that you could get the same answer with. You follow the instructions so that you can get the answer. Thank you, Bra'ari.
Thank you so much. Okay, okay, that was the answer for that. Again, because you're using equations of motion, what is it that you know? What is it that you need? Which equation you are going to use, substitute, and solve? All these were examples. We did this example here. Right, the bouncing will be something like this. The position time graph of bouncing will be something like this. They'll ask, for example, how high did it go on the second bounce? You look, the second bounce is this one, the height will be that one. How high will it go on the 3rd bound? You get that one. And how long did it take before it leaves the ground? You get the difference in time. I think one question says, how long did it spend on the ground? So this is the time it spent on the ground for the 1st bounce. So it will be this bigger time minus the smaller time. That means it took that amount of time before it bounces off. It took this amount of time before it bounces off. Okay, so yeah, that's another example. We just read from the graph. Graphs are very useful. They provide useful information, which I think we must use. They can give you a graph and say, interpret what is happening. As you see, the velocity starts at 0 and it goes to -9, meaning that the object is falling downwards. You can get how high by the area on the graph, and you can determine the time, and so on and so on. I want us to quickly do something very short, which will be very short. This is about energy. In the next few minutes, I wanted to do this one, Doppler effect. Doppler effect is about sound waves, and you must know what Doppler effect is. You get a mark for that. This is the equation given. They'll give you maybe VL and V and Fs. They want you to determine FL. Again, because of plus or minus here, use those the directions of VL and Vs as I stipulated earlier on. That says we still use Cartesian coordinates, but now you put your listener here, you put your source there. Now, if the source is going towards the listener, do you see that that direction is negative? We are going to make this one negative. If the source is moving away from the listener, do you see that one is positive there? We are going to make your Vs positive. If the listener is moving towards the source, do you see that that direction is positive? You make VL positive. if the listener is moving away from the source, do you see that it is in the negative direction? Therefore, your VL will be negative. The FL and the FS and the V are not vectors, so you don't worry about the direction. The only ones that has a direction is when the V is VL and VS, and that is how you get the directions. Now, the other point is that when the source is approaching the listener, the frequency that is heard by the listener increases. When the source approaches the listener. When the source moves away from the listener, the frequency decreases. In the same way, when the listener approaches the source, the frequency increases. The moving away, the frequency decreases. Now, sometimes they'll give you, instead of giving you the frequency of the source, they give you the amplitude of the source. That is where you must use the question C equals to lambda F is given in the equations, in the formulas, and make lambda, F the subject of the formula. So F will be the same, not C, V will be the same as V over lambda. So if you are given lambda, we are given V, you can determine F, which we'll use in the equations. That's about what is important when it comes to the Doppler effect. It's another very easy question. And it's about 15 marks. So know the directions that you use in that. Remember, anything approaching each other, the frequency becomes higher. If it goes away, the frequency is lower. And if you are given the amplitude instead of frequency, use this relationship to get your frequency. Learners, let's take it up to here for the day. We wish you all the best in your examination. Please look at the tools that we talked about. From those tools, you'll be able to handle each and every one of those questions. Even the questions that we didn't manage to get through, apply the tools and you will be able to deal with that. Learners, all the best in your exams. Dr. Morph, talk to the learners.
Yes, Ali. Guys, let me start by thanking you to be part of this sessions that we have given from August, and also to thank all the presenters that have presented the previous sessions. And I hope that listening to the different presenters, you have actually seen that the final destination is the same. The only difference is how we get there. And I want to thank Abra Ali again for being so explicit and being directive to show the easiest ways of collecting marks. And I hope that all the sessions have managed to prepare you to collect the maximum marks from your final examination and taking notes and being allowing to be educated. And from the SAIP point of view, again, I think it is proper to thank all the presenters from their universities and their affiliation with SAIP to make these sessions to be plowing back to the nation. And there's been a community service that we all endeavor in making sure that the physics is taken as one of the subjects, especially when you guys are going to the universities. I hope that the learners you have also applied to different institutions and make sure that you also apply to the funding from NEFSAS as early as now so that you can be granted if you qualify. But all the best to everyone that is going to write the upcoming examination. Thank you very much to all, and over to the office. Malume Bukhosi, you can wrap up. Thank you.
Dr. Molefe, Raali, thank you so much for the wonderful session. And thank you to each and every one of you for joining us today. It is the last session that we would have for the year, virtually for physics or chemistry. However, if you want to go through the lesson again, you can go to our Facebook, our YouTube channel, the South African Institute of Physics. You can catch up on this session and the previous sessions that we had throughout the year. Prelims, June exams, first term exams, so that you can, sort of like give yourself a refresher course before your examinations. All the best. Please don't forget to follow us on social media. Facebook, we are South African Institute of Physics. Instagram, South African Institute of Physics, one word. So please follow us to stay in touch and to know the different kind of activities that we roll out throughout the year. All the best for your exams, and we shall see you very soon in 2026. Bye-bye. Bye.